Before we start section 1.1, where we look at functions given to us by formulas, I want to take some time to make sure that we really understand the definition of a function, because we're going to hear that word a lot throughout this course. And then in the next video, I'll talk about functional notation and how to read and write using functional notation. So a function is basically a formula or an equation that has a very specific characteristic, and we'll define that in the definition for a function. But hopefully you'll notice that every single equation or formula has three main parts. Therefore, a function also has three main parts, and those parts are an input value. So every function has an input value, which is sometimes called the independent variable. A lot of students think of this independent variable as the x variable, and I put that in quotations because it doesn't have to be x. It could be n or t or any other letter, but again, most students think of that as the x value. And then every function has to have some kind of mathematical rule. And the mathematical rule tells us what to do with the input value so that we can get a corresponding output value. And that output value is sometimes referred to as the dependent variable, and students tend to think of this as the y value. And again, I'm putting that in quotations because sometimes that dependent variable can be labeled or defined as another letter besides y, like we can call it f or p or t, so just be aware of that. What I have on the right here is a picture of what I like to call the function machine. So if we take a look at this example of the function machine, notice that we have an equation here, y equals 2x plus 3, and that equation is called the math rule. And the reason why I call this a function machine is because a machine takes inputs, right? It does something to those inputs and then outspits a final product, the output. So we can kind of think of functions to work in the same way. So if I choose an input, so we say, let's suppose that I let my input x equal 4. So let's suppose our input value is 4. Then when we put it into the function machine, the mathematical rule says take 4, multiply it times 2, and add 3 to it, and the machine will give us a corresponding output of 11 because 2 times 4 is 8, 8 plus 3 is 11. And notice that if my input value is 4, then the only possible output value is 11. There's no way I can get any other answer besides 11 if this is the math formula and if this is the input value. Okay? So that's really important to note. We can take a look at another example. So let's say, let's suppose that x is 10. Let's suppose that my input value is 10. If I put that into the function machine, the math rule says take 10, multiply it times 2, and add 3 to it. And if we do that, our corresponding output will be 23. And again, notice, if x is 10, the only output that we're going to get is 23. And there's no way that we can get any other number besides 23 if x is 10. So that is what makes this particular equation a function. It's that characteristic that no matter what input value I put into the machine, I will get only one corresponding output. So let's write that down as the definition. A function is a mathematical rule that takes certain numbers, such as 4 or 10 or any number on the number line. It could be a positive number, a negative number, a whole number, a decimal, a fraction. Okay, so it takes certain numbers and it takes them as the inputs and applies that math rule, which then assigns to each input value exactly one output value. And those are the key words, exactly one output value. Okay? That's the special characteristic that makes certain equations functions and other equations non-functions. Okay, so let's real quickly take a look at an example of a function. So what I have here is an example of a quadratic equation. So I've given you a formula for the function, but I've also given you a graph of the function. And I just want us to think about the definition and confirm that this equation, which is also the same thing as this graph, really is a function. So to determine if this really is a function, we need to make sure it fits that definition. So let's just check a couple of points. Assign some input, assign some number as the input value. So let's say x is -2. Then if x is -2, we go up to the graph. The only possible output when x is -2 is 6. And there's no other point but this point here that corresponds with 6. So far it seems to fit the definition. So then y is equal to 6. Let's pick another number for x. Let's say x is 0. Then what's its corresponding output? So at 0, its corresponding output is -4. And we only get 1 point when x is 0. We only get 1 point on the function, and that's at y equals -4, no other number, right? Okay, let's try this one more time. Let's pick another number for x. So let's say x is 3. So when x is 3, let's find the output on the function. Notice that the corresponding output is -4 and nothing else. It's only -4. So 3, -4. Okay, we don't get any other point but that point. So we only get one output for that specific input. Now, we could go through and check a whole bunch more function or more x values, but hopefully you can see that this is going to be true, meaning we're going to get only one output for any input value that we get along this entire function. So if we were to pick any other point, right, that definition would hold true all the way through. I just want to point out one more thing. Some of you guys might be looking at this output and thinking to yourself, oh, wait a minute, I see -4 2 times. But don't worry about that because the definition still holds true even though we see -4 twice, right? I see -4, but notice that the definition just says that for any input value, right, it's a function if you get only one output value. So -4 is the only output for when x is 0. And then down here when x is 3, the only output I get is -4 when x is 3. I don't get anything else. So that fits the definition. We're good to go. Okay, in the next video, I'll show you an example of a non-function, and then in the third video, we'll talk about functional notation.